So I will be presenting scalable adversarial mixing for enhanced manifold learning and speaker verification. So the problem is that most of the current speaker verification systems, they struggle with robustness and scalability, especially when faced with a limited number of speakers, leading to insufficient coverage of diverse distributions in the embedding space. So the solution is that we introduced a GAN to enrich the manifold of the embedding space by generating synthetic speaker representation. And this approach allows the model to learn effectively from synthetic data, ensuring better robustness, scalability, and coverage of diverse speaker distributions. So the objective is that we wanted to improve the performance of speaker verification system without the need of acquiring more speakers and by invoking GAN to flatten the manifold space and adding unlabeled synthetic speakers. So as we can see here, our input is the MEL spectrogram to the generator, which represents a speaker encoder, and it generates speaker embeddings. Then we apply mix-up strategies to create synthetic speaker embeddings. And then these are our input to the discriminator that tries to distinguish between the real and the fake embeddings. And so the steps are, first, we created the synthetic speakers where we looked into the closest speakers in each batch using the Euclidean distance. And we created a weight vector for each synthetic speaker by averaging the two weight vectors of the closest pair. And also for the embeddings, we average their corresponding embedding for each synthetic speaker. For the discriminator, we use the Markovian discriminator to evaluate the synthetic embeddings and to improve the manifold learning. Also, we added the spectral normalization to stabilize the training. For the generator, we used the MFA conformer. We utilized the MFA conformer to generate speaker embeddings. And our adversarial objective was to make synthetic embeddings indistinguishable from the real embeddings. For the experiment, so for our data set was a subset from the Voxelab data set, which contains like 39K utterances and 1150 speakers. We ran 3 different experiments. We trained our model for 30 epochs. And first, our baseline was the MFA conformer, which scored 3.33, equal error rate. Our matrix was the equal error rate. And then we added the GAN, and we had an improvement of like around 4%. And then we added the GAN along with another loss for the synthetic speakers, which helped us to have to get a 5% improvement. So our approach achieved very good results. And thank you for listening.